So what's actually happening in the common ion effect is that, so let me define that first. The reduction of the solubility of a dissolved salt by adding a compound that has an ion in common with the dissolved salt. So this dissolved salt could be, let's say it could be this, sodium chloride. This could dissolve into Ag plus and Cl minus, although this is not a full dissociation given by this reversible sign here. So you know that basically when we are talking about KSP, we are talking about so this substance will be partially soluble and it would look something like this. So note that it only applies to slightly soluble ionic compounds, and you'll basically have like half of it being solids and half of it being aqueous ions, and there will be like a constant interchange right here. So the aqueous ions they continuously change into the solid form, and the solid form keeps changing into the aqueous ion form. That's basically what a KSP is. That's a KSP equation. For the common ion effect though, so here I've said that if I was to add a bit of sodium chloride into the saturated solution of silver chloride, well, if I just dissolve this NaCl, I'll get Na plus and Cl minus. And this Cl minus, this increase in concentration of Cl minus in the solution, it adds up to this Cl minus over here, so this first equation, which in turn, our reaction will go to the left a lot now because we have more of the Cl minus, so we'll tend to use this Cl minus to form more AgCl. So as there is more Cl minus because of the dissolved NaCl, I have to form more AgCl now in order to balance this equilibrium. My hand is shaking quite badly. So if I was to form more AgCl using Ag plus and Cl minus, and now since I have more Cl minus, I will have to form more AgCl, then that means my Ag plus and Cl minus both have a decrease in concentration. I'll find a pencil. Due to the increase in Cl minus, now they will have to shift back. The reaction will go in the backwards direction. And therefore, I'll have a decrease in Ag plus, a decrease in Cl minus, and in turn, I'll have an increase in AgCl. So due to the increase in AgCl as a ionic substance, my Ag plus and Cl minus has decreased in concentration. So due to this decrease in concentration, I can say that my KSP has also decreased. And since my KSP has decreased, well, just now we know that the KSP is directly proportional to the solubility. So the lower the KSP, the lower the solubility. So that's helping us to come to the conclusion that the solubility of silver chloride, AgCl, is decreased in the presence of NaCl because of the increase of chloride ions. And this is a common ion effect. And this explains why our definition is the reduction of the solubility. So the solubility has decreased due to this addition of ion. But indeed what happened if I actually do this reaction for you is that due to my addition of Cl minus, I'll have more Cl minus here, of course. This will help me to form more AgCl solid, which is a precipitate. This precipitate, I'm not sure of the color, but it'll form more. And if you have a actual reacting mixture, maybe just now it's just like a little bit of precipitate. Now the amount of precipitate is going to increase, and hence that's when you know you have observed a common ion effect.